Hey guys, let's pick up on page 36.
Oh, it's scary. Did you poison it? Yeah. Sure, there's something. That's gonna be over fast.
Hi guys, page 36. Go ahead and read this problem and see if you're able to set up. I just decided to space out the x-axis so the graphs that didn't feel as close together, but you can scale however way you want to. Now, there are different variations to how you set this up. You can have the nail at its maximum to begin with, or just have it at the minimum to begin with. I had it at the minimum just because I saw that the ground is what came up first. Okay, so Sam's riding his bike one day and picks up a nail in his tire. The nail hits the ground every 2 seconds and reaches the maximum height of 48 centimeters. Okay, assuming the tire does not deflate. So he hits the ground every 2 seconds. When is he going to hit that maximum height of 48 centimeters? Well, since it hits the ground every 2 seconds, so it's going to hit the ground at 0 and at 2. So where is he going to hit his maximum height? 1 second, right? Okay, so from this, we can figure out the period. We can figure out the amplitude. We can figure out the d value. Okay, for part B, it says write a cosine function. What adjustment will we make with this if we want this to be a cosine function?
Isn't it already?
Yeah, I think this is already a cosine function, right? Does it look like cosine function to you? But instead of starting at the peak, what's happening here? Starting where? The minimum, right? So if it looks like an upside down cup, then there's no shift needed. We just know that our A value is going to be what? It's going to be negative, right? Yeah. So if your graph already starts at the peak or at the minimum at 0, then you're dealing with a pretty straightforward cosine function. There's no shift involved. Mhm.
Wouldn't B be 5 of?
Oh, sorry, you're right. The 2's cancel out, but the pi doesn't go away. Okay, oh, sorry, I didn't show it. Okay, any questions with part B here, creating that cosine function?
Wait, why is there no phase shift in it?
Because this graph already starts at the peak or the minimum, right? Imagine taking this cosine graph and just flipping it over the midline. It would start here, right? Anytime it starts at the minimum, midline, max, midline, minimum. It's just a reflected version of the cosine graph, right? It doesn't feel shifted because I'm at 0. I am lined up pretty nicely.
Okay. Thank you.
Now, having said that, we could, if you're viewing the cosine graph from this perspective and then going down, then yes, it could be shifted. You could say a positive 24 cosine shifted to the right 2. You can say -2, and that'll be correct. So you have different variations, but I decided to make this without a shift. But if you wanted to make this a shift, you could. Right? Maybe if you're seeing the cosine function from this perspective. Take that graph and you shift it over to the right, then you can make the equation like this. Right, you move that red graph to the right, so -1 +1. But I chose to do it without a shift. I find it's easier without the shift, but yeah, so just to kind of show you that, this is not the only right answer, but I find this is the easiest for me. But yeah, you did a shift and it doesn't look like my answer, it can still be correct. All right, let's talk about part C. It says write a sine function. Okay, so with the sine function, what you want to do first is you want to sketch where the sine graph would be. Okay, where would the sine graph be? Now, what do you know about a sine graph? Where does it start? Starts at the midline, okay, so where's our midline? 24, okay, so, go ahead and, put this in a very, light, shading, or a different color, or a dotted line, because this is gonna be how we're going to know how much and where to shift. So if I'm going to create a sine graph, right, sine graph starts going up. We want the sine graph to complete its cycle within 2 seconds. So this feels like a pretty familiar sine graph. The good news is that your A value, well, the amplitude, sorry, the amplitude, the B value, the D value, it's all the same. But now we can figure out what can we do with this sine graph so that we can turn it into the solid graph, which is what we really want. So I'm going to fill in as much as I have without, or I'm going to fill in the equation of the dotted line and then just save space for the shift later. Okay, so are we okay with this equation as it stands is the equation of that red dotted graph? Right, same A value. The A is positive because the graph is going up, so there's no reflection. B is the same. B is the same. I'm just saving room for that shift. So the question is, how much do I shift the red graph so that it lines up with the solid graph? Which direction? Remember, we're talking about the red graph though. Right? Yep, we're moving the red graph. We're not moving the black graph. Right? So that's the thing I think a lot of students struggle with. They want to move the black graph, but you want to move the imaginary graph. Yes. Good. So you're moving it to the right 1/2, right? Because every increment, as I define it, is 1/2. So that's one interval over, and one interval is 1/2, right? So to the right 1/2. So minus 1/2.
If you reflected the sine graph, would it be plus 1/2?
Yes.
Oh,
So again, you have a lot of different variations that you want to do, that you can do, but I'm going to present the way that I think is the easiest. But if you have different variations, as long as you shift it left, yeah, so there's infinite ways. I'm just picking the way that I find is the easiest. Okay. But yeah, if you have questions about your equation, if it doesn't look like mine, I can come by and I can look at yours and confirm. Yeah, you have multiple ways to present the right answer. Okay, tomorrow on the quiz, on the partner quiz, I'll try to print out copies of, because I think we're used to these shaped graphs, so I'll print them out as for scratch paper in case you want to do your work with these graphs. These graphs won't be on the quiz, but I'll try to remember to print them out in this form since you're used to this format. Yeah.
We have hunters in the world.
Yeah, tomorrow morning, yeah. Tomorrow morning, I do have a health session, but I have a meeting at 7:45. So I'll do from 7:15 to 7:45. So I'll do a 30-minute help session. You can join on Teams or you can be in the classroom. I'll send you a link through Remind if you want to join on Teams. I'll send it tomorrow morning around like 7:10, 7:15.
Will school be open then?
Yeah.
Like in the team?
Yeah. School's open by like, 7 a.m. So yeah, you can be here. Yeah, I've had help sessions. 7:15 on and there were no issues. Okay, any questions at 5? All right, read number 6, see if you're able to work through that. Okay, what is 2.75 and 0.25? What do they represent? Max and min, right? So from that, we can find the what? Midline, yep. What do you think the period is if it takes um, 1 second to get from max to min?
2.
Yes, question.
Doesn't it say the first minimum is 2 seconds after the maximum?
Oh, wait. You're right. My bad. So this should be over here, right? Sorry, I thought I read 2 seconds after we started, 2 seconds after the maximum height. Sorry, 3 seconds. But yeah, from 1 to 3 seconds, how much of the period has occurred? Half. Good. So we know that our period is going to be 4 seconds, right? Okay. All right, so my period is 4. Okay, so this kind of looks like a cosine function, right? But it's been shifted, so every second we're going to hit the next interval here. Okay, so there's a nice nice shape of our cosine graph, but obviously it's not a cosine graph without some movement, right? But we can find our A value, we can find our B value, we can find our D value. We'll worry about the C value at the end. A values distance from the midline to the maximum. We know our A value is positive. Looks like the graph is starting above high, so I think we can let the A value be positive. I'm sorry, 2.75 is the max. So sorry, the A value is only 1.25, right? Okay, so let's create what this graph looks like, right? This is without a shift. And without a shift, that means the graph is going to start on the y-axis. So you can put that imaginary graph here if you like. So we have to understand that this equation that I have right now without the c value is shown by that faint dotted graph. So we have to ask ourselves, how can I move this dotted graph to the solid graph here?
Like, what would it be? Like, it'd be -1, right?
Yeah, that's right, because we're moving it 1 unit to the right. So -1. That will turn the dotted graph into this solid graph here. Any questions with that step there? Remember, you're moving the dotted graph to the solid graph. You're not moving the solid graph. Solid graph is your end goal. It's not your starting point. Any questions? Now it says write a sine function. Okay. What if I follow this graph to where it's supposed to go? Because if I go back one second, where is this graph going to be? It would be at the midline, right? So is this graph a shifted sine graph, or is this a nice sine graph without any shift? It's a sine graph, right? So we're already showing a sine graph. So when we write our sine function, we don't have to worry about any shift, because if I just made the graph a little bit longer towards the left, I see that it's already starting at 1.5. It's already starting at the midline. So I can just write my sine function with the same a value, same b value, and same d value. With no shift. Okay, part D, what is the height of the rope at 2.75 seconds? You can plug 2.75 into either equation. Just make sure you're in radian mode. Okay, see if you can get about that decimal value, 0.345 meter. Yes, question.
Can you explain C again? Like, why did it be phase shift?
Why would it not be a phase shift? Okay, so we know that this graph, I have it as a max, right? And what's my interval? My interval is 1 second, right? And the way that it works is it goes from max to midline, minimum, midline, max. What if I move to the left of the graph? I was in midline, right? And if I draw that graph, then I see that, oh, this is a nice sine graph without any worries about my shift. So I didn't have to worry about any shift because this graph is already a sine graph. Okay, let's go to the last page. Anybody have issues with part D? Okay, does anybody still need to look at this page that I have up here? Okay, I'll leave it up here for another minute. Go ahead and read number 7 and see if you're able to draw the graph and identify all the information to be able to write an equation. Raise your hand if you still need this page. Everybody okay? A Ferris wheel is 60 feet in diameter, makes one revolution every 50 seconds. So we saw a Ferris wheel problem before, so we can kind of take that knowledge. 60 feet in diameter, which means that our radius is 30 feet. That's going to help us. Okay, one revolution every 50 seconds. What does that tell us? That's period. Yep. If the center of the wheel is 35 feet above ground, what is that 35 telling us? Center is the midline, yep. So if we know the midline is 35, how can we find the minimum and the maximum? What's the highest that this Ferris wheel can go if the center is at 35? Yeah, because of the radius, right? So the radius is distance from the center to the top, as well as the center to the bottom. So the radius is also our amplitude, right? It's also our A value. So 35 minus 30 is 5. 35 plus 30 is 65. So Ferris wheel, we typically get on the Ferris wheel at the lowest point. So I can start here. Midline, maximum, midline. Oops, midline. I got the 5 from the fact that my A value is 30. And so the distance to the minimum is gonna be the D value minus the amplitude. Because everything's symmetrical, right? I know that. I'm gonna have the same distance from the midline to the max that it is from midline to the minimum. Okay. What function does that look like to you? Cosine, that's been what? Reflected, right? Because cosine looks like this. A cup that's right side up, this is a cup upside down. There's no shift because it's starting right at the minimum. But it is reflected, so my A is negative 30. Okay, we know our period is 5 or 25. Sorry, our period is 50. So the interval is just period over 4, which is going to be around 12.5. So every interval, I'll just go over 12.5. Right, so if I keep adding my interval, I can reach my period of 50. So the next part is asking, and we're just going to do an estimation and make the calculator kind of do the work for us. At what time is the graph or is the rider going to be 50 feet above ground? So 50 looks like it's somewhere in this range, right? So we're somewhere between 12.5 and 25. So we can kind of just test some numbers and try to get as close to 50 feet as possible. But you know it's going to be somewhere in that 15 to 20 range. Make sure you're in radian mode. So I plugged in 15, looks like it's close, 44 feet. What you can do is you can hit the up arrow button. You can just go back and just change the numbers and just test them out, see which one will get you close to 50 feet. 16 is close, 17. 51 feet. Okay, so I know somewhere between 16 and 17 feet, probably closer to 17 feet. So I just say around 17, sorry, around 17 seconds. Okay, try number 8. Sorry, let me see here. Sorry, I meant for us to skip. Sorry, I meant for us to skip number 8. Let's not worry about number 8 here. But let's see, how much time do we have? 11:30. Okay, a few minutes. Did everyone pick up the quiz review that I asked some of us to take from? Okay, so come up and grab one. If you did not grab one from last Friday.
Which one? Forget it.
Oh, gosh, yeah. I'm gonna sort of your time. Is there anything loud? Oh, yeah, you have two. Oh, okay, go. I do, I'm part of the back. I'm so hard.
Yeah.
I'm so hard. You also get mine.
Yeah, my one is free. I'm gonna see.
Either way. Mom, you ruined the joke.
I did for that one.
We all did something.
We did that for this.
Yeah.
I'll get the right. What? What?
I can't. What'd you say?
Yeah.
That sounds trustworthy.
He didn't say here. What am I supposed to say? What was I supposed to say? Didn't even say. I don't know. I didn't say the money either.
So tomorrow, when you guys come in, I will have the desks separated in pairs. But again, you don't have to have a partner. But if you are gonna work with a partner, you're gonna work with one partner. There's no groups of 3. Okay, it's either one person or groups of 2, and that's it. Okay. When you come in, go ahead and sit down, and as soon as the bell rings, I'll pass the 2 different versions. So person's gonna get one is gonna get white color sheet, and then the other partner will get a probably blue color sheet. I haven't decided which color yet, but you and your partner will not be working on the same version of the quiz, but you can talk to each other and help each other out. Okay, you can bring your calculator. I will give you scratch sheet. I'll give you scratch graphing paper as well. Help session tomorrow at 7:15. I encourage you guys to work through the worksheet. I have the key there for you. Your quiz will just be 1 page, okay, just 1 page. But you can use scratch sheet to do as much of your work as you like.
Will it be just like the review?
The review is longer than the quiz.
Oh, okay.
Yeah.
How many questions?
It's really just one extended question. One question, and he's gonna ask a lot of things.
What is this?
Yeah. go ahead.
I'm not sure how to get there.
What?
Yeah, so I'm looking at this graph here. This is my graph.
She's fine.
0, 4.5.
I need to check.
Well, you can go check. Like, you can subtract in for t and see if it gives you. Then just keep testing it out as well. You know that's a smooth curve. It's gonna have to be some time and. If you're off, then that's good. Nope. You're pretty close. That's good enough. Because you're good that it starts, the max is at 1 second. And the minimum is at 3 seconds. So if you go from max to min, how much of the period have you accomplished? Half. You've done half the period, right? So the other half is gonna be from the minimum to the max, so you know it's gonna be 4 seconds. If you ride a Ferris wheel, most Ferris wheel, yeah, you should just start at the bottom. So that's how I think.
It's my section today.
Yeah, I know.